Ooh, yes, it works. Lecture sounds so serious. So I'm here to talk about Elixir, and when I got the email and I was invited to speak here, I was really excited because it's always nice to hear that there's not only interest from like startups and companies in using Elixir, but also from students, universities. So I'm really glad to have this opportunity that we can talk about Elixir and so on. And before we go into the language, okay, I just want to tell a little bit of my story, right? How it came that why creating a new language. And to tell this story, I want to go a little bit back in time about 2008, 2009. Who here already heard of the Ruby on Rails web framework? Okay, and who here has used Rails? Okay, quite a lot of people. And I am one of the contributors of the Ruby Rails framework. And in 2008, 2009, they released Rails 2.2, right? And one of the biggest things in this Rails release was they were saying that Rails 2.2 is now thread safe, okay? And the reason why we had this release and we had this thread safe thing is that time, right, 5 years ago, or more than 5 years ago, we already had some pressure because we knew that our machines are not getting any faster, right? We don't have computers with 5 gigahertz, right? So what was happening is that we were starting to have more and more cores. We're starting to buy machines with 2 cores, 4 cores, right? At the time, and then we say, well, if I want to have my software running faster now, my software needs to run on all of those cores efficiently, right? And in most of the imperative languages, right, like Ruby, C, Java, the main abstraction for using all the cores of your machine, they are called threads, right? So with threads, you can like run an application and it can use all the cores of your machine. And in Ruby, it's not different. And when we released Rails 2.2, when we said that Rails 2.2 is thread safe, what we meant is that now you can get your Rails application and run it in production in a way that's going to use all cores of your machine and it's not going to break, right? So to me now, some years later, when I hear the word thread safe, for me it's a very funny word, right? Because thread safe, it doesn't say that the software that you're writing is going to be fast. It doesn't say it's going to be efficient. It just says that it's not going to break, right? Which is like the minimum the minimum guarantee you're supposed to give. It's like, you want to hire someone to build a software, and then you ask them, hey, is this software going to be fast? And then they, maybe. Is this software going to be efficient? Maybe. And they're like, what? Okay, which guarantee you can give to me? And they say, well, I guarantee you that it won't break, right? It's kind of really silly, and this is actually the only guarantee we have here, right? And we released this Rails version, and people started using, deploying Rails to production using those threads, and bugs were showing up, right? Because when you're working with multiple cores, right, you have a lot of things happening at the same time. Things that are happening concurrently, right? One core is doing this, the other core is doing something else, and then you start to have issues with like 2 threads, right? 2 cores trying to change the same space in memory, and then things boom, things blow up. So we started to run into those issues, and they were very hard to fix. They were even hard to reproduce, right? People were saying, oh, I just have this issue in production in some particular times, and then how we can fix, right? How we can reproduce and fix this bug. So everything was very, very frustrating, and then at some point I decided to stop and think like, well, if concurrency, right, is becoming more and more important, our machines are starting to get more and more cores, right? And we want to write efficient software that's going to use all the machine's resources properly. I need to find a better tooling than this, right? I was not happy with the tooling we have in those traditional languages, right? In those imperative languages, be it C, Java, Python, Ruby. And then I decided to study, right? So what are other people, other languages, other communities doing to solve this problem? And it was, while I was doing this study, this research, that I found a category of programming languages, right, called functional programming languages. And to me, the thing that resonated with me the most when I found functional programming languages is that when it comes to write concurrent software, they have two rules that are very important. So the first one is that the state is explicit instead of being implicit. And this is a big change because, for example, when we're working in object-oriented languages, right, one of the reasons of the object is exactly to encapsulate state. You are hiding the state, right, behind the object and behind the methods, right? And then someone can inherit from that class and they're kind of like having those methods all on top of the state. And that makes not only your software harder to understand, but it also makes it very hard to write concurrent software, because many of the issues you have with concurrency is like when you have two things trying to change the same state, right? So like two threads trying to change the same place in memory, okay? And if the state is hidden inside the object, it's very hard to find when those issues come, right? So they said, okay, so let's make the state explicit, right? Because state is complicated, so it should be easy to think about it, okay? And being explicit makes it easy. And not only that, right? Besides making the state explicit, we are going to avoid changing, mutating the state as much as we can. So in imperative languages, if we have like a list or an array, and you want to add a new entry to the array, right? You can add it directly, right? If you want to delete, you can go and mutate. You can go and remove the element from the array or from the list. But in functional programming languages, if you have an array or a list and you want to add a new element, you get a new array or a new list, right? If you have a dictionary and you add a new key and a new value, you're going to get a new dictionary built on top of the old one. So we never mutate, right? We are always transforming, right? And the steps, they are always explicit. Okay? So when I was studying, it's like, wow, this really resonates, right? I think that if I follow those rules, indeed I'm going to get better software, and I'm going to get a software that I will be able to run concurrently, much more efficiently, and without any of the headaches that I was having. And while I was studying all those functional programming languages we have out there, I like to say I fell in love with one, right? I fell in love with Erlang, okay? And the reason why I really liked Erlang was, I was reading about his story and everything, and what really resonated with me is that how Erlang came to be, right? I like to tell this story. So you just had a talk about Erlang, right? And so you probably know at this point that Erlang was a language created by Ericsson. And what I find really nice is that 3 decades ago, right, when they had the engineers at Ericsson, they were thinking, well, what was the problem that we need to solve, right? They were saying, oh, we need to build telephone switches, right? So a telephone switch is a machine that, for example, if person A wants to call person B, the telephone switch is going to connect, right? Those two people, and so they can talk. Right? But they were thinking, what are the requirements, right, that a telephone switch needs to solve, right? What we need to solve with this? And they said, well, not only we want to connect person A to person B, but we want to have a lot of people talking at the same time, right? So we're going to have a switch and person A is talking to person B is talking to someone else, and so on, right? So they said, okay, we need to handle like as many connections as possible, right, in the switch. We want it to be very, very efficient. They knew that, the switches, they need to exchange information between them, right? So you have a switch, person A wants to talk to person B, but person B is already talking to someone else from another switch, right? So they need to be able to exchange this information and solve this kind of problem. So they said, well, this needs to have an idea of being distributed, right? Like different machines, they need to be able to talk to each other, and so on. And then they have a bunch of other interesting use cases, right? So you just heard about hot code swapping, and I like to make a joke that we don't receive phone calls from our cell phone operator saying, hey, we are going to be in maintenance mode from midnight until 1 a.m., so please don't use the phone. Right? So they said, okay, this thing needs to run all the time, right? We cannot be shutting it down for maintenance and things like that. So, they designed this great language and this great virtual machine, and it was used most for telecommunication for a good period, right? And then I think it was around 2003, 2004 that Erlang started to gain traction again in other communities. And it started to gain traction for building stuff for the web, because developers realized that this use case here is not really different from this use case, right? You have a server, right? You're running or a web application or a chat or a database, and it needs to have a lot of clients. One of those clients is the browser, right, for our application, right? And then you need to talk to internal endpoints, and you want this to be efficient. You want this to handle as many concurrent connections at the same time. So, Erlang started to gain more and more attention, right? And then we have like a lot of interesting use cases, right? So Amazon and Facebook, they use Erlang. We have application companies like Ericsson, Motorola still using it. Heroku, if you deploy an application to Heroku, they use Erlang in their routing layer, right? So every time you access your application, it's passing through a layer of Erlang. We have Riot, which is a whole database written in Erlang, and many others, right? There is one use case that got very famous 1 year ago, or maybe a little bit more, which was about WhatsApp. They were acquired by Facebook by 19 billions. And before that, they were writing interesting blog posts. And if you look, you can find talks from the engineers at WhatsApp on how they were able to, in a single machine, they were able to have 2 million connections at the same time, right? So WhatsApp, for those who are not familiar with it, it's an application that you run on your phone, and you can send messages to anyone who has WhatsApp too, right? It's a messaging application. And you say, okay, so we have like 2 million devices connected on a single machine, right, and exchanging information. And they post details about this machine, right? So it's a very good machine. You have 24 cores, 96 gigabytes of RAM, but that's exactly the point, right? I want to write my software, and it's going to run efficiently, be it on my computer, right, or when I put it into production, and it's a machine with 24 cores, right? It's going to be able to use all the resources of the machine efficiently. Cool, right? So this was the introductory part, right? So tell a little bit about the story of functional, when did the functional programming, a little bit about Erlang. But the title of this talk is Idioms for Building Distributed Applications, okay? And that's what I want to focus now. It's kind of the bulk of the part, and then it's kind of the bulk of the talk. And then I'm going to talk a little bit about Elixir at the end and a little bit of live coding, okay? So, when we're talking about idioms, right, I want to focus on Elixir here. And we say, if you ask, like, what is Elixir, right? Elixir is a functional programming language. But to me, it's more than function, right? It's about being a concurrent programming language. And it's actually more than being concurrent. It's about being a distributed programming language. Okay, and we're going to talk exactly what those things mean. But just as a curiosity, if you talk to the Erlang creators, right, that's exactly their perspective, right? They say when they created Erlang, they wanted a distributed language and distributed runtime, right? You're not looking at functions, you're not looking at concurrent. You're looking at distributed, and everything else came as a side effect. Okay, so let's look, so let's say, okay, I want to try Erlang, I want to try Elixir, right? How you're going to write your software, and what are the idioms that we need to know, okay? So, if you're writing imperative code in Java, Ruby, C, those languages that I'm saying, this is your code, okay? It's this ball, this chunk of sequential code, right? You write the code, and that code is going to be executed as you wrote it, right? Mostly it's going to be sequential. And when you're running in Elixir and also in Erlang, for this part of the talk, there's a difference between them, right? So when you're running Elixir code, it's not really different, right? We have this sequential code, but this sequential code is not, your whole application, right? It's just a very small thing that we call process. So if you're talking about idioms, what are the idioms that we use to build applications with Elixir? We just learned a very new word, right, called process. And this process is not the operating system process. It's a process that runs inside the virtual machine. And what we do is that we create many of them, right? So in the WhatsApp case, they said that they had like 2 million connections. They had one process per connection, okay? So in that case, they had at least 2 million processes running in that virtual machine. So the idea that those processes, they are very tiny, they are very lightweight, okay? And we can run many of them. And the interesting thing is that those processes, they are isolated from each other, okay? And because they're isolated, we have a very nice property that they can all run at the same time. Okay, so we start to have this idea of concurrency because the processes are isolated, so they just can do whatever they want to do, right? And they're not going to conflict with each other because they are isolated. And then if for some reason you need those processes to communicate or to exchange information, we do it explicitly by message passing. So we send messages between them. They're sending messages, so if they need to synchronize or exchange information, they do it by messages. So one message say, hey, give me this data that you have, and then the other process later sends a message, okay, here's the data that you asked, and so on, right? So we have processes, we now learn that we now know that they are isolated, and because of that they are running concurrently, but we have a lot of other features also, just by following this design principle of being isolated processes. And in order to understand what else we get from this, let's zoom in. I'm going to choose like 4 processes here for us to zoom in and try to understand a bit more what is happening behind the scenes. Okay? So let's imagine that this is a web application, right? So as a web application, we're going to have one process that talks to the database to get information. We are going to have a web process that is, is listening to the socket, to the TCP socket, and making requests and handling those requests for our application. We can say that we can have a process responsible for handling statistics like who is connected or information relevant to our application. And we have another process for sending emails, right? So maybe, someone creates a new account in this application and we need to send an email, right? Because they're isolated, we get a very interesting property here, right? And in order for us to understand this property, I want to do another comparison with the imperative languages that we use, right? So in those imperative languages, what can happen is the following. Let's imagine someone creates an account in your application, and then you do process whatever you need to do, and then you want to send an email. If there is a failure when sending this email, right, it can actually bring your whole application down, right? If we do that in languages like Java and Ruby, right? And what those languages do to work around this issue is that they use try-catch, right? Or they rescue exceptions. It's actually a very common term in those languages to say, oh, I want to catch an error or catch an exception or rescue something, right? And the reason for that is exactly because if something happens in the mailer and we don't catch this error, it's going to blow up, right? And it's going to blow up your application. It's going to bring everything down. It's going to bring your whole system down, right? And if we stop and think about it, we are getting the conclusion, it doesn't make sense, right? The equivalent to this would be if you're using your application, like you're using your computer, and then you're sending an email, like in Outlook or a mail client, and then for some reason you can send that mail and your whole computer crashes, right? Your whole computer breaks and you need to restart it or something, right? So, it's really weird. And in Elixir and in Erlang, we got rid of this idea completely, right? We avoid catching errors, we avoid catching exceptions as much as we can, exactly because those processes are isolated. If the mailer crashes, it's not going to affect anybody, right? Because it's isolated, everything can continue running. In fact, we even say, let it crash, right? If something goes wrong, if for some reason you can't send an email, or you went into a condition that you don't really know about, what you're going to do, just let it crash. Because we have those things called supervisors. And the whole goal of a supervisor is to watch those processes. And in case they crash, in case something goes wrong, they're going to say, well, I'm going to restart a new version of this process, right? To continue doing whatever it was doing. Okay? So here's a very powerful idea, right? It's a very powerful new idiom, right? They're not talking about let it crash, and they're talking about supervisors. And those supervisors, sometimes they have supervisorship, which has other supervisors, and they start building what we call the supervision trees, okay? And then at the end of the day, what we do is that we get this whole supervision tree and put it inside an application. So an application is something that we can start and stop as a unit, and usually when we are writing Elixir or Erlang code, right, those applications is how we package our software, right? So we put everything in application and we distribute it. So, you know, we learned a lot of interesting new words, right? We learned about processes, supervisors, and then we have those supervisors supervising the processes, and we put everything inside applications, and they are all communicating with message passing, right? And because of this design, we got a lot of features, right? We got concurrency. We are now thinking about let it crash, and this idea of let it crash is what starts to give us, puts us on the way to write fault-tolerant software, right? Why is that? Because if something goes wrong, we know that we are going to restart it, right? And why restarting is important. Why restarting? Why is it better than using try catch? Why restart is a good strategy? Restart is a good strategy exactly for the same reason when you're using our computer and then things start to work not as you expect. What do we do, right? We go and restart our machine, and then suddenly everything comes back to work again as it was before. So it works because every time we restart, we go back to an initial state that's guaranteed to work, right? So when we start our machines, we go back to the good state that the manufacturer tested a lot, right? And when we restart the process in our application, we put it again in that initial state that is the one that the application started and that we tested a lot in our tests and so on, right? So this whole idea of let it crash with supervision brings us, puts us in the way of writing fault-tolerant software. So we get all of these, right? And we also get distributed, right? But I haven't talked about it yet, right? It's in the title of the talk, how to write distributed applications. And I haven't talked about it yet. So let's get it out of the way. So we have this slide, right? So now we have our processes, they are sending messages to each other. And the way we can write distributed software for this design is that the message passing is actually abstracted for us, right? So it doesn't really matter if those processes, they are in the same machine or different machines, right? The runtime abstract the message passing for us. So we can easily write software in a way that it runs in a single machine. And then if you have two machines, you don't need to change a lot of your code in order to be distributed. You just say, instead of sending a message to this process in the same machine as I do, send this message to the process in the other machine. I'm going to do a little bit of live coding soon, and then we can see some examples of this. Okay? So those are the idioms, right? And everything I said here applies both to Erlang and Elixir. So you can be asking, well, so what is new with Elixir, right? Why Elixir? What Elixir brings to the table? Why would I choose to use Elixir or Erlang or any of the other languages that we have in the ecosystem? Okay, so this is the last part of the talk. Okay, and I just want to talk a little bit about Elixir, and in order to do that, I want to talk about the language goals. Okay, so what we want to achieve with Elixir. So the first goal is compatibility, then it's extensibility, and then it's productivity. Compatibility is the easiest one. It just means that everything I said so far, right, all those idioms and those ideas that we have in the virtual machine or runtime, they are going to work just fine with Elixir. Okay? That's the first goal. We're going to be compatible, right? We're not going to sacrifice the features that the VM are giving to us in favor of other features. We're going to remain compatible. In fact, you can call Erlang from Elixir and Elixir from Erlang with no cost at all. There's no conversion cost or anything. So all the libraries that we have for Erlang, you can use for Elixir and vice versa. So that's compatibility. The second one is extensibility. Okay, and there is this quote in order to talk about extensibility that I really like from Guy Steele. He taught this at the end of a talk called Growing a Language, which is a really good talk. And he says, Now we need to go meta. We should now think of a language design as being a pattern for language designs, a tool for making more tools of the same kind. Okay? And what he means by that is that today the computer science field is so wide, right, that it's impossible for us to design a language that is going to work fine for all fields, right? It's going to be work well in all the domains you need to tackle. So a language, in order for it to be useful, in order for us to really be productive, the language needs to be able to grow, right? The language needs to be extensible, right? It should be a pattern from which you create your own languages from there, right? It's not like your literal language, right? But you can extend it to your domains. So in Elixir, we have a couple features that help us achieve that. And I'm going to explore just one of them for this talk, which is the idea of macros, okay? So in Elixir we have macros, and the thing about macros is that they allow us to be really expressive in extending the language. So here is some Elixir code for unless. So in many languages they have unless keyword, which is the opposite of if, right? It's like a negated if. And unless in those languages, they are a keyword. They are something that's known by the compiler, right? Or it's known by the parser. It's something that it's in the language, and you cannot implement it in your own code in that language, right? It's something special. But here in Elixir, it's just a macro, right? So in Elixir we have unless, and this is literally how it's implemented in the source code. So the whole idea of a macro is that instead of receiving the evaluation of the arguments, instead of receiving that the result of is number x, it receives the code, the representation for that code, and the macro is going to run a compilation time and transform that code into something else. Okay, so a lot of Elixir is implemented in Elixir itself, exactly because they have macros, right? I think it's like 90% or 92% of Elixir is written in Elixir, which is really, really good, right? So here's an example of a macro, and I don't want you to focus on the details of what is a macro and how it runs. I want us to talk about what we can do with it, right? So here's an example. Here is how we write tests in Elixir. Okay, so we define a module called math test, and then we have a test framework in the language called XUnit. And we just say, I want to use the XUnit case functionalities. And then you just write, I want to test some like basic operations, and then I say assert 1 plus 1 is equal to, okay? And so here's an example that we are getting the language and extending it to a particular domain, right? So we are extending it to the test domain. So now we have this test function and macro that we can write our tests, and then we have assertions that allow us to say exactly what we want to assert in our tests. And the cool thing here is that, for example, assert is a macro, and by being a macro, it can look at the code and say, hey, I can see here you are trying to compare two numbers. So if for some reason something goes wrong, right, in your assertion, we can provide a really nice report. I'm not sure if you can see this, but basically what is happening here is that if something goes wrong, we say, well, you expected these to be 2, but we got 3, right? So those things do not match. I can show another example in the live code, okay? So another example of using macros to extend the language to other domains. So you have a library in Elixir called Ecto, and Ecto is a language integrated query. With Ecto you can write code like this, and we are going to compile it to a SQL query behind the scenes that you can run in your database. So you can say, well, from each ping post, right, if the time that the post was published was less than now, and the author is José, I want to order all the results I created by. And this is going to be a query that will run in the database. And what's even nicer is that this is already very, very expressive, but because macros work at compilation time, we do most of the work of converting this to SQL during compilation, right? So when you're running your software in production, it's going to be really, really fast too, okay? So this is cool, right? Those are examples that we are getting the language, right? This is not part of the language. This is a library, right? the libraries are able to get the language and extend it to those particular domains. This is really, really nice. And at the end of the day, it boils down that it can make us really more productive, right? Because we can like teach the language new tricks, right? And that's our third goal, right? Is we want the language to be productive. But you can say, well, how can you really say that language X is more productive than language Y, right? How can you measure that? And I agree, it's hard to say, right? Like, oh, how can you really measure productivity? And so the way we chose to embrace productivity in Elixir are by things that really make sense and they directly affect our productivity, which is documentation, right? You're not going to be productive in any language if it doesn't have documentation, or the libraries of that language do not have documentation. The documentation is poorly written, or the documentation is hard to access, right? So we said, okay, documentation is going to be first class in Elixir, okay? We also need to have a good tuning, right? You're not going to be productive in a language where to start a project, you need to manually create 5 files and then write a make file to compile those files and so on. So we need to have a very good tooling and experience out of the box. So in Elixir, we have XUnit, which is a test framework. We also have IX, which is a shell that it's really, really powerful. And we have Mix, which is a build tool that knows everything about your project, how to compile, how to run the tests, and so on. And we also have a package manager, right? So it is called Hex. And if you have someone has solved the problem, you can just use their package in your code. So in order to show that, I'm going to do, this is kind of what I had to say. So I'm going to do the rest of the talk to do a little bit of demos, show a couple of interesting things and questions, right? So let's see. Can you hear me in the back? Cool. So yeah, so let's do a little bit of demo. So yep, sorry, that's not going to work. Okay, so let's do it. So I'm going to start with the more exciting things, which is we have something called IX, which is interactive Elixir, and it just knows how to run Elixir code, okay? And I'm going to start IX, and when we're starting, you're not required to do that, but we are going to see later why I did that. I'm going to give it a short name of full, okay? And when we give a short name when we start in IX, it means that it can be connected to the distributed mode and then it can talk to other machines. Okay, so I'm starting IX with a short name of full, okay? And then here I can type whatever, right? Like 1 plus 2, and then I got 3, I can type any Elixir code. What I'm going to do here is that I'm going to define a module, okay? This is a little bit cliche, but we're going to get there. Called hello, which a function called world. And this is going to print hello world when we execute it, okay? So that's it. So we define the module here in the shell. And now if I call hello.world, it's going to print hello world, right? Basic, right? Nothing really special here. But here's one thing that's more interesting, okay? So I'm going to start another interactive Elixir shell and give it a name of var, right? But this time, if I try to run hello.world, it's going to fail because we defined that module hello just in the other shell, right? This shell has no idea what is the module hello. But what we can do here is that, so here's my second shell, right? So we can go ahead and say, I can actually run code in the other node. So to do that, I'm going to say, well, I want to I have a module called node, and I have this small function. So I want to run a function in this other node, and all I need to know is the node name, okay? So we're going to go back to the first shell, if my computer lets me, okay? And here's the name of the other node, right? This thing here, right, between parentheses is the name of the other node. So I'm just going to copy that and say, well, I want to send a message to to execute this code in this other node, and this code is going to be hello.row, okay? And here we run it, and it works, right? It created hello row. And it works because this node got this instruction, and it sent it to the other node, and the other node says, oh, let me process it. And then it says, oh, I have the hello module, and I have the row function. So it executed that, right? And created the result. The coolest thing here, folks, is that you can see that even though the code it ran in the other node, hello row was still created here, right? Hello row came back, right? So what we did is that when we ran the code in the other node knew that this node was the one who started the message. So it says, well, if you want to do any kind of I/O, I'm going to send you back to the place that started to execute this code, right? So this is really, really cool. And this is what you want, right? So if you're running in production, what you want to do is that you want to connect to production code, right? And run some commands. And if there is any output, you want to see it on your machine, right? You don't want to have it created in the production machine. You want it to come back to you, right? So this is just a very simple example of how we already got very easily, right? Two different nodes to talk, and we could very easily do like. Now it's kind of easy because everything is in the same machine, but if we have other machines in the same network, we could easily make them talk to each other. Cool. Okay, cool. So this is one of the things I wanted to show. Something else I could talk about is, so talking about tooling, this was IX, right? In fact, Elixir. The other thing that comes with Elixir, so as soon as you start to install Elixir on a machine, we also have this thing called Mix, right? Which is a build tool. It knows how to create new projects, compile, and so on. So let's suppose you go home, very happy today, say, hey, I want to play with Elixir thing. You install it, and then you say, okay, I want to create a new project. So just go and say, mix, new, I'm not super creative today, so I'm just going to call it hello. So mix new hello, and it's going to generate a new application, right? And then we can jump into this application and run the tests. And then it's going to compile and run the test for you. So it's really easy to get started, right? And start doing your first steps, okay? I was talking about documentation, so let me show you some interesting examples. So I'm going to go into this application that we just generated, and here is the module hello. It generates an empty module for us. And then we'll start writing documentation, okay? So this is a module. I'm going to write some module documentation. Hello, does interesting things, right? And the cool thing is that we can write code snippets inside the documentation, and we are actually going to test those code snippets for you. So if you say, well, I expect 1 plus 1 to be 3, let's make it fail so you can see the report, right? So I write this code, I save it, and now if I run that, okay, we are going to get a failure, right? And the whole idea here is documentation being first class, right? It's awful if you're reading the documentation and it has outdated examples, right? You try to like, wait, what? I'm getting a different result. Like, who is wrong, the documentation or me? So we have a lot of good tools to motivate people to write proper documentation. Not only that, if you have code snippets, you can write them as you would write in your shell, and you're going to test and ensure that everything works for you, right? On the topic of documentation being first class, what we can also do is that after we documented the module hello, I can come to the terminal and say H for help, right? And say, I want you to show me kind of the help for the module hello, and it brings the documentation here for you from the shell, right? And we have people working with editors that is adding those features exactly to editor sheet, right? So you can like shift click, or I don't know which documentation your editor uses, but it's going to go and show the documentation, and you can see the examples and you can see everything, right? And this works for everything in Elixir. So you want to see the documentation for the plus operator, right? You just say, I want the help for the plus operator, which receives 2 arguments. That's why we have the /2, because we also have the binary operator plus that has just 1 argument, right? But you can say, oh, we have is number function, so I want to see the documentation for it, and you can just navigate and export the code, right? Not only that, before I forget, this is also application or all the applications running your system. So if you run this observer start, right, it's going to start your observer, which is this amazing thing here. It's kind of small, I don't think it can make it big, but it has information about your system, like, what is the total of memory it's using, and of that memory, how many is being taken by processes and other stuff. It has load charts, so you can run observer in a production system. This is going to be much easier now. We also have load charts, which gives you information. You can run this in the production system, right, and see what is happening there. We have an applications tab that actually shows all applications that are running in this particular node, right? And we can use it. So remember that I was talking about the supervision trees and so on. We can see those here, right? So IX, right, which is the tool that we are using to run the shell, it has a very straightforward supervision tree. It's basically a line, right? But we can look at Logger, which is an application that Elixir uses for logging. It has a little bit more complex one, but it's still quite small. We can get information about the running processes in your application and a bunch of other stuff, right? So these all come for free because we are just accessible, and it's easy to access the existing Elixir, Erlang libraries, okay? So this is kind of what I wanted to show you the demo, but you can always go back to it and you can show other stuff if you want any questions. Just to finish this, right? So if you like Elixir, we have a website, elixir-lang.org. We have a getting started there, right? And it's going to get you started with the language. We also have some advanced guides for those who want to really go deeper into the language. If you like, if watching something is more your style, last year we had Elixir conference, right? So we have, if you search for Elixir Conf, you can find all the videos that we had for the conference last year. And then there are a bunch of interesting videos, both like from starting, like, what is Elixir, what Elixir is about. And we also have videos on how to think in Elixir, right? It's a different way, the point of this talk is to say Elixir is a little bit different, right? When it comes to writer software, we have some peculiar idioms, and we have talks talking about that, talks about people using it in production and so on. And we have also a lot of books, right? We have books from the major already publishing companies, so Pragmatic Programmers, O'Reilly, Manning, they all have books on Elixir, and there are more books coming out, so more resources for you to learn. We have screencasts, okay? And just as an addendum, we also, so every year, Google organizes something called Google Summer of Code, okay, which is the idea that Google pays young students to work on open source, right, during the summer. I took part of the Google Summer of Code a couple years ago as a student, and now I am taking part of the Google Summer of Code as a mentor. So we created this thing called Beam Community, which aims to mentor students on different open source projects that run on the Erlang virtual machine. So we have like Disco, which is a distributed framework. We have Mongoose IAM is also there, which is an XMPP server. Elixir is one of the projects. So if this idea of the Google Summer of Code is interesting to you, right, you can go check out the Beam community. And it's also very like, so if Google Summer of Code is interesting to you, and you want to code in Erlang or Elixir during the summer, check out the Beam community. But the Google Summer of Code is not only about Erlang and Elixir, right? It's very likely that they have projects in your favorite language also there in the Google Summer of Code. So I just wanted to mention it very quickly, right? And it's a really interesting project overall. When I was a student, I really enjoyed it. It opened up a lot of connections with important members of the open source community. And that's it. So go check the Google Summer of Code if you haven't yet. And if you really like Elixir and Erlang, go check the Beam community. If you have questions, come ask me. Mihal, he's also there on the right side. And he's also mentoring projects in the Beam community. So if you have questions, you want to know more, please come talk to us. It's a really, really nice program, okay? Yeah, so that was an addendum, and this is the end of the talk. So this is Elixir. Go check us out, go check the website, and that's it. Thank you.